computer. Okay, I'm recording this. Hello everyone, this is the second live session for HMGT400. In this live session, I'm going through the individual assignment 2 and exercise 3. The exercise 2 is very similar to exercise 1. For that reason, I'm not going to review that, but if there are any specific question, Hida or Ali, if you have any question from exercise 2, I can answer your question first.
No, I'm
no
good.
Questions. Okay. Individual assignment 2 is very similar to individual assignment 1. And I'd like to go through the rubric system to see which piece is important for this assignment, because I have reviewed your first individual assignment and I noticed most of the time the student did a very good job on the analysis section, but not a good job on the discussion or results section. And based on my feedback, you have a chance, when I say you, I mean anyone in the class, if you receive a grade less than 90, you have a chance to update your assignments based on the my feedback and submit next Friday, next Sunday with individual assignment 2. Let me review this. Let me go through the rubric system for one of the assignments. Okay. Give me a moment to open this. And all right. Okay. Let me share my screen. You can see what I'm looking at. Yeah, this is my screen, and still my computer is working on. Okay, here you go. Working on this. You cannot see anything yet. Okay. The rubric has. Let me review from here. This doesn't work. Finally, got something. No, let's check. Okay, here you go. The rubric has 1, 2, 3, 4, 5, 6 sections. The first section is critical thinking. Usually, most of you have had a great job on this section. So as long as your assignment has all the section for the individual assignment, you will receive the 20 points. Data analysis and this is the objectives of this class is just in developing your statistical skills. So the most part of this, as these 2 assignments, actually all the 3 assignments, and the final exam is just improving your qualitative and qualitative skill, more likely to quantitative analysis part. For the data analysis, you will receive 30 points. Describe findings, 15 points. Discussion, 15 points. Attention to the instruction, and grammar and APA format, 10 each. And for the data analysis, as I reported in an example in the class, I do expect to see discussing about the describe the data sets, report to table, at least 2 tables, 1 table to describe the variables, 1 table to discuss the descriptive analysis, 1 plot, or if you are working with RStudio, 1 plot, box plot, or an density plot. If you are working with Excel, at least 1 plot, box plot, or bar chart. And then talk about the data. Which data did you use for this assignment, and which type of test you have used for this assignment, something like this. This is for the data section. And then you kind of go and report this and describe your finding. Describe your finding does mean you say, okay, this is the mean, this is standard deviation for 2 population, and then so discuss about the variance. Why do you think the variance is really high? Why do you think the variance is so low? Why do you, how do you describe the t-test, why you are accepting, why you are accepting the hypothesis, why you are rejecting the hypothesis. And this is a discussion, and this is for the findings. And for the discussion session, you should discuss your finding based on your own thoughts and provide some policy intervention for policymakers. If someone want to read your paper and use this for intervention, what's your suggestion? This is the for this part. And so whenever you have all of this, at the end of the discussion, you should add a limitation. For that limitation, limitations you should discuss. Okay, this is a student research. So, or if you have any limitation with your data, any limitation because of the novelty of your research, especially for you here. For example, this is really completely new area. We don't expect to see lots of articles here. And that's type. These are type of the limitation we have. Is as long as you follow the instruction for the class, you will receive the 10% percentage here, and usually most of the students will receive the last section. In the class, the grade has a variance between 100 and 75, so 25 percentage variance. It's too high. I don't expect us to see the variance like this. But if you receive my feedback and update that, this is the chance for you to resubmit your assignment to get higher grade. And also use this feedback to do not repeat your mistakes, your error. Make sure about that. And if you're working with Excel, you really don't need to report all of the Excel output. I don't need to see that. I don't need to see a square root of this, a square root of that, different type of a t-test. I like to make sure you know what you are reporting. If you are using the SPSS, you should know why you are using the pair t-test. For this class, I suggest to use RStudio. The RStudio by default use unequal t-test and using the wall test. If you are using a pair t-test for the SPSS, you have to discuss why. If you are using different tests for the Excel, you should discuss why. This is for the rubric of this assignment. Okay, let me go through the class and show you. Okay, this is good. This is student receive higher score. This is fine if you see that. Hopefully she's okay with this. Okay, let me go back to class. Okay, discussion. If you go to the discussion and scroll down to still waiting. Okay, scroll down to the class instruction. This is instruction for the individual assignment 1 and individual assignment 2. There is 4 data sets here. Medicare, Minnesota, Imaging Center, Minnesota Admission, and Minnesota Cost Report data. And this is an example. As I explained the first live session, for this example, let me review this example one more time, because most of the class, yeah, I can say most of the class did not consider all of this instruction. Okay, the first page is a title, but please don't use a by default word, anything else. Please go with this approach. Introduction, very short introduction. The method section starts with hypothesis, data, materials and method, variables. You should use this table to report the variable. The method section, use this paragraph, modify that based on your research, and the processing for the data analysis, discuss what you did, why you did, and something like that. In the results section, discuss your findings, add any graph or tables. I really need to see a table like this. Please don't put any output from the SPSS, any output from the Excel on this. Whenever you put all the output of the Excel or SPSS, my first thought is you really don't know what you are doing with them. Otherwise, you could complete this very simple table. I really don't like to report, okay, there's a pair t-test standard error from the t-test, t-value, f-value. You really don't need to report that. As long as you report all of them together, my first thought is you really don't understand any of them. You just try to just follow these numbers that you didn't see the means of these numbers. You really need to know what's the n, what is the mean, what is the standard deviation, what's the p-value, what does it mean? So this is very simple table, and even in a very famous journal, Lancet, New England Journal of Medicine, any of these high impact factor journals. So you really don't see a very complicated table. Maybe they use a complicated method, they didn't use a complicated table. The table should be easy to understand. With one look, you should get anything from the data, from the table. Okay, every table has a title and a source, because if someone only look at your table, you should understand 50% of the story. So most of the students have not reported the title for the table. So please do that for the individual assignment 2, and then the discussion, and then the limitation, and then the conclusion and policy recommendation. Sometimes, depending on the journals, you may go at the limitation put at the very end of this assignment, at the very end of the conclusion, but usually this is the structure I just suggested, and it is the same it is. Hopefully by the for the next week for the assignment 2, I really like to see all of you improved. If you are received 100%, please keep your grade, keep doing great. If you receive 98, I expect you to get 100. If you receive 80, I do expect you to receive 100, because you know the feedback. And if you have a chance to submit your individual assignment by Wednesday night, the Wednesday should be on this time, right? The 10th. I will review that and give you the feedback of previous, not final feedback, just a short feedback to fix your error and send back to me by Sunday. The due for this assignment and the individual assignment 2 is a Sunday, the 14th. Okay, this is for the individual assignment 2. Any questions so far for individual assignment 2? Auli, Heider, or Victoria join us.
Not for
Victoria.
Me. Yes, because I just joined, so I missed the first part of it.
Okay, please watch the video, Victoria. I review the rubric system, and I say, okay, these parts are important for me, and I just review the individual assignment 1 and 2 example, and say, so please work this as an example to develop your individual assignment 2. Okay. If you are working individual assignment 1, if you are still working, the due time is was Friday, but anyhow, if you didn't submit by now, please do it by Sunday night. Otherwise, I'm not able to accept that. More than Sunday, after Sunday night, it's after 7. Please do not submit anything after 9 p.m. tomorrow night. Any individual assignment 1 submitted after that time, I will not review that. Okay. For the individual assignment, okay, this is for individual assignment 2. I'm gonna walk through a few examples based on the different data sets. We have 3 data sets. The first data set is Medicare. It's a imaging data set. The imaging data set is just for MRI and a CT scan or PET CT, anything like that's related to the imaging procedures are in these data sets. This example compare the clinic and the And you know, the concept, the structure of all the codes are similar. For the individual assignment 1 and 2, you just need to work with the mean function, standard deviation function, mytable function, ttest function, and the box plot function, 5 function. The density plot is an extra function, but really 5 functions, not more than 5 functions. And for each assignment, you should just need to report the mean, the standard deviation, and n. It's very, very, very simple. For example, in this example, I reviewed that in the first individual assignment 1. So I'm going to go with a different sample for Medicare National Little County. And let me give a privilege to all of the students who are here. Heather, I know your topic. Ollie, what's your topic? Are you still with us, Ollie? Okay, Ollie, not there. Victoria, okay, Ollie, are you with us?
For which assignment?
Individual assignment 2.
I don't remember it.
Okay, if you don't know, please take a look. I asked Victoria, your individual assignment 2, I think it's I exam between black and white, correct?
Yeah.
Okay, let me go with an example. James, what's your topic? James, are you with us? Okay, James, you are not with us. Now I see you are here, but you are muted. Okay, I'm gonna go with Victoria example. Heather, I know your topic.
Check.
Hi, James.
How you doing, sir?
Oh, what's your topic, James?
It's so many. Is exercise 2?
No, individual assignment 2.
Individual assignment number 2. Oh, the one that we're working on right now it has to be turned in on Tuesday.
Uh-huh.
I think I'm doing it on.
Oh, you have not submitted the first one yet, right, James? I graded you today, so.
Oh, okay.
Yeah, please review my feedback and you have a chance to resubmit that. What's your second assignment?
The one I'm working on right now, I think it has to do with. Is that the one with the compatible, the high, the medium, and the low?
That's exercise, James. I'm talking about the individual assignment. Something like
mine had to do with the discharges of Medicare for.
I see. Okay.
The 1,000 people that had it or were discharged from the hospital.
Discharge for who? For which procedure?
If they were case-sensitive persons with diseases.
Oh, I see. You are using your own data set.
Yes. Yeah.
Okay.
No. I used the data sets from that was sent from the Medicare. I mean, not the hospital one, the second group of for country and each city and each county of each state.
You know, for the discharge, you should also compare 2 type of. Can you just look at the topic you submitted and let me know what's your topic? I'm gonna go with the Victoria topic now. Please take a look, Ollie and James. Please take a look at your topic as long as I'm looking at this 2 topic.
Okay.
The topic for the Victoria, and then let me know what was that. Okay, Victoria I exam, correct? Okay. Black and white.
Got it.
Okay, black and white I exam. You should use the Medicare National Data by County, and this is the code. I'm gonna share this code with you after this meeting. Please send me an email, Victoria. I will share the code with you, okay? Okay. Oh, this is the data set, Medicare National Data. First thing first, you should read the data. For reading the data, you should make sure that you put the Medicare National Data CSV file from here, this file, right click, save as, save link as. You already did that, but for the other student who have a similar topic, save link as to drive C UMUC. To drive C UMUC folder. So the root should be this one, CS/UMUC. Okay. Okay, whenever you have this, so you should read the data set. You are reading the data. and look at the names of the data to see how many variables they have. These are all the variables for the Medicare National Data by Counting. So for the Victoria subject, we are going to compare the percentage of Medicare eye exam between black and white. So if you are going to use any other topic, for example, between black and white, let's say lipids, black and white. Let's say ambulatory care. Let's say diabetes, anything like that. You should just change this one. This is the variable should change. This is black. So if you have comparing between, for example, diabetes, you should just compare this. You should just replace with this.
Okay.
Anything else is the same. So I'm gonna just back and undo this just to go through the eye exam. For the eye exam, this is two variables. Black, eye exam mean for black, and mean for the white. These are the means for black, these are the mean for white. This is standard deviation, black for white. This is the observation, mytable comment for eye exam for white, and this is the eye exam for the black. And this is the t-test. The t-test is 2.2 e on power of -16. It's very small numbers, maybe it's 0 actually. There's a really significant difference between them. And look at them in 62.4, 66.2. So there's a 4% difference. Then look at the box plots. This is a box plot. Okay, here. And click export, copy to clipboard, copy plots, go to the Word document and paste it. That's very easy. And then you're gonna go with density plots. Run all of the code together, and this is a density plot. The blue line is a white, the red line is a black. Does mean most of the time, look at the means here. Most of the time, after 60%, 40% of black more likely to use eye exam than white, but overall, all of this place, all of the blue line is over red one. It does mean most of the time, white population more likely to use eye exam than black population. And then you should put all of this information in the graph in the individual assignment one in the example. This example in this draft, and then you are good to go. Or if you have submitted individual assignment one with a similar subject, you can use individual assignment one and just modify that for the two. Okay, this is for this. James, did you have any chance to look at Victoria? Do you have any questions so far?
So for assignment one, do you, after using RStudio, you want us to save in Word document? Because my exercise, I did it in an HTML format.
I'm not talking about the exercise. Are you talking about the exercise or individual assignment? I'm talking about the individual assignment on this one.
Yeah, I'm also talking about the individual assignment. So do you want us to save it in Word, copy and paste and save it in Word document, or is it?
Yes, sure. You should follow this instruction.
Okay.
This is individual assignment one, and you should update this text, this document based on your topic.
Okay.
Okay. Any other question?
So,
Okay.
Professor, you said?
Ollie, what's your topic?
My topic for second assignment is comparing average annual percent of diabetic Medicare
Okay,
enrolled.
diabetes Medicare. Okay, perfect.
Yeah.
Diabetic between black and white?
And between 65 to 75 having hemoglobin.
Okay, A1C. Okay.
A1C between states 1 and state 2.
Okay, which two states are you looking for?
Maryland and Virginia.
Okay. Which and Virginia? Which state?
Maryland and Virginia.
Oh, Maryland and Virginia. Okay.
Yeah.
Okay, let me review your topic. It's very similar to, because that's almost a little bit different with the first one, because with the for example I have provided, because you should subset your data. Okay, let me go through a topic, open file. Hopefully I have the codes. Okay, wife, beneficiary, hemoglobin H1C. Region and mailer, here you go. Okay, this is your codes, Ali, and you can look at this video even, or just use this video to use for your topic. All the numbers is real numbers. Or I send me an email after this just to have the codes, but really, Victoria, just use save for you because I review the codes. For sure to get the plot, you should run in your computer, but for all other the numbers, you have this, all of them numbers here, all the numbers is here. So for your assignment, you should be comparing A1C, right? Hemoglobin A1C between two states. So the topic is this one. And this data is Medicare National Data by County. You should run this data. And then these are all of the data. And then for that specific topic, you should use this variable hemoglobin overall, because you are comparing Virginia and Maryland. So first thing first, you should subset two data sets. The first data set is of Virginia. You are generating a data set for Virginia, and you are generating a data set for Maryland. And then you're gonna go through the means for this. The means for Virginia is 87.37, and the means for the Maryland is 85.62. These are the real numbers. You can use it for your assignments. And the standard deviation is 3.5 and 2.08. And the number of observation in Virginia is 134. The number in the Maryland is 24. You know, for someone who is watching this video, and then, you know, whenever we are using the t-test, we should have more than 30 observations for every variable, for each variable. So here we have, for the Maryland, we have a 24. I know this one, but I'm ignoring this for this individual assignment too. But by default, we should have more than 24 observations for Maryland, for example, at least 30 observations. I know the differences between, I'm not talking about it, because for this class, we never talk about the, no, we are using the t-test as a parametric test. We are not talking about a non-parametric test because we didn't teach on non-parametric test. Just everyone gonna stay with the t-test. And then we're gonna compare the means between two states. If you run this, you can see the mean is 0.001. There is a significant differences between Virginia and Maryland. And then you should look at the box plot. This is the box plot comparing hemoglobin overall between Virginia and Maryland. And this is the density plot. So you have this one, and you have this one. Please use please use this structure here, modify that based on this result you have, and submit your assignment. This is and if you submit by Wednesday, I will review that and give you my feedback. So just in case there is some major problem.
Thank you.
Any question for me?
One more question.
Go ahead, please.
You said for resubmission of assignment 1, when is the due date?
You know, you already submitted that, and I provide your feedback. So
I said for the resubmission, when?
Yeah, for the resub, you can submit within the assignment 2 next Sunday. You have 1 week.
Next week Sunday.
Yeah, I mean okay. the 14th, right? Yeah,
okay, thank you.
Sure, you're welcome. You have 1 week to work on this.
Okay, thank
the 14th. You. Yeah, it's for all of the students who received my feedback today. You have a week to work on that, because I don't expect you to work 24 hours, 48 hours. You need time. I really need, you know, you need to know that you're knowing what you are doing. I'm trying to teach in a way you learn the statistic. Later you can use it for your own work or job. Okay, Victor, any other question, Ali, for me? Okay, no question. James, any question?
Yes, sir.
So, did you look at your topic?
I did. I just pulled it up. It took a while. So mine was comparing discharges for ambulatory care sensitive conditions with 1,000 patients enrolled between North Carolina and Florida.
Florida?
Yes, sir. So
do we have those data sets?
Yes, we do. And
is it in the Medicare National Database?
It's in the from Medicare National Data CSV.
But I don't see the variable. What's the variable here? This is all the variables.
So at the
you are
end,
talking about the discharge.
Discharge. The last row at the end.
Oh, I see. Are you gonna see the number of discharge?
Yes, sir. So I use the overall because instead of
you are doing good. You are working with Excel, correct, James?
Yes, sir. Yes, sir.
Okay, good. You are very good with Excel. This is good. No problem at all. Okay, you should go with this, and for the Excel, you should filter your data, or just because this is a 2-1 variables, and you should filter by you should have it just only Excel. Let me open this data set because I really like to explain for a student who are working with Excel. Okay, this is the data for the Excel users. And if you're using the CSV file, make sure to save it as Excel file.
Yes, sir.
So basically, you really don't need any of these variables. You just need these two variables. Number, discharge, overall, right? Maybe we don't need this one. Let me hide them. Number, discharge, overall. You need just these two variables. These are everything you need here. And you can filter and you said 2 states, North Carolina, Florida, right?
Yes, sir.
Florida, North Carolina.
Now, I had a question. My thing was, now what you sent us to compare, I sort of changed it because I just didn't feel that it was a good question, hypothesis question. So I changed it to a point, and I think to just, instead of comparing the discharges, I used ambulatory care services preventing Medicare patients with ambulatory case sensitive conditions from being
you changed that?
I did, from being hospitalized from discharge, because I only had one data set, which was the overall. Okay, and I didn't go, and my next one would be black and white. I could use those two. So, but when you look at the differences, you have more people that's being hospitalized still through ambulatory care services than that are being discharged. And it's a big, huge group. Only 7% of those are being sent home when 93% of them are being hospitalized. So I use that to say, well, what are ambulatory care services used for? If they are being along the lines of not taking care of patients, but still hospitalizing, why do we need it? Get it? And so I used also the data set of the amount of money Medicare was giving to those places for each patient that was enrolled.
As the extra analysis?
Yes, sir. Yes,
okay,
sir.
That's good. So, but you have the analysis for discharge over here, right?
Yes, sir. Yes, sir.
Okay, that's good. So you have these two, right? And then you have these two, and then it is very easy to go with this. You have these two data sets with these two variables. And let me copy this here. I don't like to, let me copy over here. Is the special value. This is Florida. This is a discharge, right? This is North Carolina.
I like how you get rid of yours. Yours is gone. Mine.
Yeah, this is the following discharge. I like to just, you know, everything simple is beautiful, right? So you should stay with this. This is the, and let me give you, I'm gonna put everything here. This is the M, this is the average or mean. This is the standard deviation, this is the standard error, and this is the, okay, I don't need this one even. For the N, you can just go with the count function, right?
Yes, sir.
Count function. Okay, let's go here. Count function for this. 67, this is full. Let me give one more space here. So
67 for one, and then 100 for the North Carolina.
Yeah, 67 is for Florida. This is Florida, this is North Carolina. I should go with the count for this. Okay, this is the fourth, and the average, you gotta go with the average. Then you can copy this and change to average, right?
Let's see what my average was. My average was, where's my date?
Average.
70 for the Florida.
That's,
It was 70.18, and then for North Carolina I got 61.91.
that's completely true. This is this, and what you have for standard deviation.
Standard deviation, I have 21.44 standard deviation for Florida and 16.49 standard deviation for North Carolina.
Standard, did you use S or P?
I use S. I use, oh, let me, you know, in Excel, you put in the, and I did the long version where you subtract it, and then at the end,
I use the filter for that.
Yes, sir. Yes, sir. And then
but
it was the,
even anything you use, you should have this. Do you have the 2116? Same here.
21. I have 21. Wait a minute. I'm flipping back and forth. I have standard 21.44 standard deviation for Florida, and
yeah,
16.
the same. Even because there is a big sample. Even you use the P, they're gonna get the same.
Right. Okay. Good.
Okay, this is standard deviation, and you know how to compute the P value, right?
Yes, sir. And I got a P value for both 0.00865.
Okay. Okay, so for anyone who are using this Excel, let me go through an example to show how to use this. I was working so hard on several paper. I really need to see which of them is here. Is it this one? Yeah. Okay. I have. Let's look at this. Mean is okay. Standard error. I have to compute this one. Let me copy this. You should compute the standard error, right? Standard error is equal to the standard deviation divided by a square root of these numbers. This is the standard error. When you have this, you can compute using this formula, right? This formula is here. So you should write the codes. This is the codes. We have, let's see, we have 17.36, 61.95, 2.64, and 1.65. Let me copy this from here. I don't like to write all of them. Okay. This is the codes if should be this one, mean first population. This is the first population. minus second population. This one minus this one, square root of this, divided by n. This is a t-value, right? To get a p-value from the t-value, you should use this formula. Cancel it. Activated here. Let's copy this only. Let's copy everything from here. Let me put it here. Paste here. Let me change this. This is the absolute value of this. And the maximum number you have is 100, right? Because we are going to use. Do you have the same thing here?
Yes.
Okay, that's it. I like to, the reason I just work is because for the Excel user class and to get the, and you can go with this, right? You can have a Florida, North Carolina. $60, 61, get the box class. I'm in the bar chart. That's it. And we can have the title here, and that's it.
Gotcha.
And add this to the class. This is for the Excel user. Thank you, James. James, also I reviewed my feedback for the individual assignment one. You have a chance to review that and submit. And you did a great job on the analysis, but please modify your assignment and submit individual assignment too. If you can submit both of them, one of them actually by Wednesday, I will review that if there's any chance or if there's any major problem, I can give you feedback. But I really expect you to get 100 for both. This is my expectation.
Let me ask you something. For assignment 2, though, the 3 category. So is it?
That's the exercise. I'm going to review the exercise.
Okay, don't worry about it. All right, I'm sorry.
That's the individual assignment 2. Okay, I think I review everything. So also for the imaging data center. So please go back to my first live session. I explained that there. If there's no other question, I'm going to the
Excuse me, Professor.
Yes, Ali.
I'm also using an Excel for my assignment. Does it matter? I think you use RStudio to explain it. Does it matter?
I use RStudio, but still the number are the same.
The same process. Yeah. Okay.
Any package will not change the numbers.
Okay. Thank you.
But if you're gonna work with Excel, you can follow the same approach I use for the James and do it.
Okay.
But you can compare your numbers with my numbers, but I don't expect it to see much difference.
Okay.
Yeah. Okay, sure. Open file, and we're gonna go through the. Maybe I have them here. Do I have? Recent exercise 3. James, are you using Windows for the exercise? Are you using Excel for exercise 3?
I'm using Excel. So I took your advice and tried to download RStudio again, and I got the R codes. But what happened was I kept getting error messages at the bottom of my.
Yeah, you should install the R first and then RStudio second.
Yeah, so I sir, I did it. I took it loose and did it again. I said, no, it's taking too long. Let me just go ahead and do it.
Yeah. Are you working with Mac or Windows?
Windows.
Yeah, you know, sometimes take time. They reset your computer because RStudio is sitting on R. So you first install the R, open the R, make sure the R is working. Just open, don't need to run anything, and then install the RStudio. It is much easier to work with RStudio for the ANOVA. For the ANOVA, the other way is just for every single variable, you run a regression.
Okay.
So then you can get the same result. Because you have a categorical variable, right? You have a Herfindahl index cat, that's a variable.
Yes.
And you have 14 different variables. So y should be that herf cat in the Excel. And for every single variable, you should run a regression. This is the most easiest way to go through that. Otherwise, I wrote a code in Excel to compute that. That's a really long way. And there's a video in the system and explain. It's really hard to do that. It's good to know, to learn how to compute, because the way I'm working with Excel, I'm not using the function.
Okay,
I'm writing the code in Excel to get the result. The reason is because you have 14 variables each, and if you write only for one of them, you can compute the other parts. That's copy and paste. Okay, this is, I'm working through these codes for the RStudio users. I will also look at the ANOVA test for the Excel users, but the easiest way to go is just go with and run the regression, because the ANOVA is kind of regression, right? Because you have more than 3 variables. The coefficient for the regression is the ANOVA F-test. That's the easiest way to go with that, James.
I'll try it again.
Yeah. And for this exercise 3, you should go with ANOVA test, right? The exercise 3 is here. Let me open this. Hopefully I have this here. I don't have it here. Okay, let me see. Close. UMUC. This is here. Chair modification. Okay, exercise. For the exercise 3, I should go and complete this table. Competitive market, moderate market, low competitive market, and ANOVA test. And if you use the RStudio, you just need to go with this. It's still the same data set. Even if you are working with Excel, it's still the same data sets. And this is the root for the Windows user. If you are using the Mac, the root should be this. And if the root, this is for the Mac users. I call it tilde / documents. Documents, this is correct. UMUC HMGT400. And you should have UMUC folder in the document in your Mac. I'm muting this. If you're working with Excel and you like with RStudio and you like to see everything in the exercise in the text file, you should unmute this in comment. And if I run this everything together, I will have a file here in my computer in drive C, UMUC Vic3. Going through this drive C, UMUC Vic3. Okay, this is it, right? 6:05:551 p.m. This is entire analysis I have here. Jim, you see this much easier than Excel?
I see.
Yeah, Yeah, that's and this is the magic of RStudio. This is the word of plot, you know, because nobody like to read a long paper. They like to see, look at the plot and see what's going on with the COVID in the US with one map only. No one like to see entire table to see all the observation, and that's because of RStudio is much easier to go with that. Okay, this is the individual, this is the means, 0, 1, 2, and if you look at the codes, but anyway, if you like to work with Excel, that's completely fine. And that's this, but it's still you should know about the 0 is a high competitive market, 1 is moderate, and 2 is a low. So if you look at this code, 0 is high, 1 moderate, 2 is a low, and then is it correct, right? Let me make sure I'm telling the same thing. Okay, let me copy this from here and paste here. 0 is high, 1 moderate, 2 low. So this is the means for high, moderate, low. These are the standard deviation. These are the numbers. And these are the p-value. These are the ANOVA test. But for the ANOVA test, there is a p-value, right? A p are more than f, because we have a t-test for the we have a p-value. We have a t-test for the comparing two samples using the t-students or t-test. But we have an F value. Whenever we have more than 2 observation to population, we're going to use a F value. And the F value is F value. This is the F value, 24. But the P value is meaning the same thing as a t-test. So any P value more than 0.05 is not significant at the 5%. Any less than 0.05 is a significant at 5%. So you should just report this one in the table for this one, in this table for this one. If any of you are using Excel have a problem, please contact me. I would be happy to help you.
So where can you show me where beds are on this RStudio? Where beds are?
Where is what in the RStudio?
Where the beds, for the number of beds?
Oh, number of beds. Yes, sure. The number of beds is this one, right? The N. You mean the number of beds? You mean the means, right? Or I mean the number? You mean that? Okay. Let's
I see. So
are you talking about this column or talking about this column?
Yeah, the top column for hospital beds. What I have is 219 for the number of.
What is your number?
For the N, I have 219.
Oh, N. Okay.
Yes.
The N is this one, James.
Right.
219. That's correct. 209. 219.
219. And for the other N, I have 13, 32.
That's correct. This is here.
And then another one I have 1480 or something like that.
1479.
Okay, yes. For me, I have to take the one back from the standard deviation.
Yeah, maybe you included the header.
I got you. Okay.
Maybe
all right, I'm on the right track. I'm good.
Okay, good. And yeah, you should have the same. These are the ends. You should have the similar end with this. Right. This is the end for the same order of this table. 1 till 14. Right. These are this end for the second part. For this. These are the end for the third one. Even the student who doesn't have access to computer at the moment, they can look at this video and populate the table. So I'm just reviewing that. Make sure you have this. And this is the p-value, right? This is the p-value for the hospital bed. This is the p-value for the employer. This is the p-value for non-paid worker, for internal residents, system member, benefit, cost, hospital beds, Medicare, Medicaid, discharge, Medicare discharge, Medicaid discharge, percentile index, benefits. No, I think that was the last one, right? We don't have any benefit here. Yeah, that was the last one. And then in the question, in this, I was working on some other package, sorry, so that's right. And in this question, there's 4 questions, right? To compare the following information, I explained that, and what is like, use the density curve and compare hospital cost and revenue. If you're working with Excel, this is fine to just use a bar chart and compare the means between them. What's the impact of being in a high competitive market on the revenue and cost? Please look at the revenue and cost here. Hospital revenue and cost, and look at the p-value. Is the p-value significant? Then you can discuss this, see which of this market has a higher, and then discuss about that. If you like to see the impact of all other variables, you should run a regression model. Also, if you like to compare each market, this market with this market and this market with this, because we have, when we have a 3 market, so we have 1, 2, 3 market, right? 1, 2, 3 market. The 1, 2, 3 market, you should, if you're gonna run a t-test, you should have one t-test 1 versus 2. You have a t-test 1 versus 3, and you have a t-test 2 versus 3, correct? You should run 3 t-tests for this to understand. And this is in the RStudio. If you are working with Excel, you should go with that. This is the t-test for this one. Here, this is the p-value, and this is the t-test here. Let's try to put the t-test in some place. Okay, here you go. Okay. These are the ANOVA tests. Okay, density. If you like this density, this is a part of the code to give you the density plots in this RStudio, but and these are the t-tests here. These are the box plots. You should run this, and these are the box plots. I just try to use color to give you the better plots, just different type. Let's look at the last question. Okay. Please discuss your finding and please copy everything. You have all the plot. If you'd like to receive 100%, great. Please copy all the plots. If you're working with Excel, please make sure to use 1 or 2 box plot to compare the means and revenue. This is what I want to talk to, and if you like to see everything in the console, mute this line and run everything. If you mute the line and run everything, you can see everything in the console, right? And some students asked me, because they were not able to see entire numbers for this. So the way, if you are not, this is for example for one more variable here. See, there's not all the variables you should give more space to this, and even run the code again. Then you can see everything here. Okay, everything is here now. The benefit of looking at the console is you have a line of the code. You can see which line is specifically for the numbers. It's very easy to understand which line is for which part. And we have all of them here. And this is a no because there's no one to see. And if you like to see entire plots, so you should just click on give more space and click back and run again, because if you just give more space, your plot is not going to be good plots, not beautiful plot. But if you give it this, run again whenever you have more space, then you can see, and you can walk through the graph with back and forth, back and forward to keep here. Okay, this is what I want to say you for today. I'm here for any questions, class. This is 6:02, so I'm using 2 minutes more of your time. But if you have any question, I'm here to answer. No question, class?
Sorry, Professor. I thought that
Hi, Maria.
I thought this was going to start at 6. I see I'm late. Would this be posted? Would this Zoom be posted? Okay, perfect.
Yes, Maria, yes.
Okay. Thank you so much.
Sure. And Maria, because you know, I just submitted the feedback for the assignment 1 and 1, so I gave a student 1 week. If any student who received less than 80, if they like to resubmit the individual assignment 1 without penalty by the end of next week, this is the last chance to review my feedback, go through that, and then resubmit individual assignment 2 by next Sunday, the 14th of July.
Okay. Can I ask you a question regarding that?
Sure.
So can I share my screen?
Sure, yes.
Let me find where my assignment is at. Because I was a little confused on how to read RStudio.
James and Olive, if you'd like to leave, this is okay.
No, I want to, no.
Okay, you want to stay? Okay.
Yeah, I want to see, because if I download it, I want to see how it's.
Yeah. Oh, Maria, I think I didn't give you permission to you to share.
Oh, okay.
Let me just give you permission. Okay, let's go. Can go. No. Okay, see RStudio.
So I believe it's this.
This is for individual assignment 1?
Yeah.
Okay.
So I just have a question. Because I thought that the p-value, if I was reading it correctly, I saw that this isn't the p-value?
It is the p-value.
Because in the assignment, it said that okay, so can you please explain, so if the p-value is less than 0.05, then it's significant, correct?
Correct. So
this one will be considered insignificant.
No, this is significant because this is 0.90 and then 36.
Minus.
Because this is 3.6 e on power of minus 10. If it was in e on power of 10, it was not significant. But it's e on power of minus 10. It's going to be 0.90 and then 36. It's very small number. This is actually 0.
So you said it's 0.9036?
No, I'm talking about this. If you just use, and it's going to be 0.0, right?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 90, and then 36.
Oh, okay.
Yeah, it's very small number. It's very zero. It's actually 0, right?
Okay, got it. Okay, that makes sense. Whenever it's like e to the negative.
Yeah, because you report maybe only the first part and didn't report the e on power minus 10, and for that reason maybe you concluded that it's not significant. I don't remember that. I reviewed your article today, but let me see. I have your feedback here. If is it okay, I give you the feedback only for that section. I think you did a good one here. Oh, here, yes, that's it. The p-value is e on power minus 10.
Okay, so, I was having trouble understanding that.
Yeah, that is significant.
I was trying my best to learn how to read the graphs. So for figure 2, this density, that's probability density, correct?
Yeah, this is density, yes.
And where does the like the 0.00, 0.04, and 0.08 come from?
You know, the density curve is you know, the histogram, the normal distribution. Do you know the normal distribution?
No.
No, okay. The normal, if you look at the 60% till 100% on the red line,
Yeah.
this is exactly the pure normal distribution. The normal distribution is happening when the 50%, whenever the mean is the middle of the graph. So for example, if you stay in the middle of the graph, the bell-shaped graph,
Yeah.
if the right side is equal to the left side, you have 100% equal distribution.
Okay.
The density plot highlight the differences and report you the density. Density doesn't, what does it mean, the density in the population? The density in the population does mean number of population divided by the distance between two. For example, if you divide it by the area of the land, it's happening the same for here. This is the area of the land under the graph.
Okay.
For example, you know, the area under the land, it should be 100%. If you just multiply the area under the red line to this number here, you should get 100%. The same for the blue. If you see, the blue is a longer graph, and then the density is increased from 0.05 to 0.08.
Okay. Okay. Oh yeah. Okay. I'm terrible at statistics, so I've been having a hard time with this, but for the most part, the videos that I've been watching from your class have been helpful.
Okay.
So
Glad to hear that.
yeah, those were my only two questions.
Okay. Okay, great. Yes, James, do you have any question for me?
No, I was just watching because if I catch up and do it this way too,
Okay.
I think, you know, as I look at hers, I see how she puts it in and it's there.
Mm-hmm.
But as I look at what she is doing in Medicare, right, her enrollees, I'm trying to figure out how that transcribed down to the bottom or into her group. So I'll catch it. I'll get there. It just takes. I just got to download it, I guess.
Okay. Okay. Okay, that's good.
All right.
One more question, Professor.
Go ahead, James. Go ahead.
So for this code, I know you provided the code, but I'm doing I will be comparing the eye exams. How do we create our own codes, or?
Maria, I reviewed the eye exam before you join us, and send me an email. I share the codes with you.
Oh, okay.
I also reviewed that for the Ollie.
Oh, perfect. Okay.
Yeah.
All right.
For the Victoria. Yeah, for the Victoria.
Thank you. I appreciate it.
Yeah, sure. You're welcome. Okay, and thank you for joining us, James and Maria, and all of us. All of you just leave the good session, and this is the end of the session today.
Okay, thank you.
Thanks.
Have a good day. I'm gonna post this video to the class later this evening.
Okay.
Okay, take care, everyone. Have a good day. Bye. Bye. This is the end of live session. Goodbye, class.